In the last video we saw formulas for permutations and combinations, and today I want to look at some properties of these formulas. The first one is that NCN should always equal 1. If we run it through the formula, like 10C10, I would get 10 factorial over 0 factorial, 10 factorial, which is kind of unusual. For it to equal 1, that would mean that 0 factorial has to equal 1, and 0 factorial does equal 1. Using ice cream, we could imagine you go to an ice cream place that has 5 flavors, and you want to get a 5-flavor cup. You can only get it one way, by getting all 5 flavors. NC0 with the formula, I'll use 10C0 for the formula for seeing how it works out. Okay, that becomes the same thing as we just got, so it also becomes 1. And to use the ice cream example, if I want a cup with no flavors, they can give me an empty cup one way, so it's 1 and not 0. Also, anything C1 is just going to be itself. We can see why that is. We could use this formula, 10p1 over 1 factorial, because 10p1 is just 10, and 1 factorial is just 1. And here's one that's not as obvious. NCR is always equal to NCR minus 1, and I mean n minus r. In other words, 10C2 should be equal to 10C8. A good way to see why that is to run them both through the formula, and one would turn into that, and the other one turns into 2,8. In other words, these two things are the same, so they are equal to each other. If you imagine the ice cream scenario, one person goes in and gets this 10 flavors, one person gets a cup with 2 flavors in it, and someone else gets the other 8 flavors. So for every 2-scoop cup you could make, somebody else could make an 8-scoop cup, and it'd be the same number for each. So I could ask on a test, 31C28 is equal to 31C question mark, and that would have to be 3, because 3 plus 28 is 31. If I were calculating out 31C28, I'd probably first turn it into 31C3, and then just use 31P3 over 3 factorial, 31 times 30 times 29 over 6, cancel, and I'd be left with just 3 fairly small numbers to multiply together. A final property of combinations is NCR plus NCR plus 1 equals n plus 1 CR plus 1. This one's going to take some explanation. First, let's just see if it even is true for any example. Let's just see. 5C2 is 5 times 4 over 2, which is 10. 5C3 is the same thing as 5C2, because 2 plus 3 is 5. So those add up to 20. On the other hand, 6C3 is 6 times 5 times 4 over 3 factorial, which also becomes 20. So at least for that example it worked, but it's not clear that it's always going to work. So I'm going to show you an example. Say there's 34 students in a class, and I want to make a 5-person committee. And here's a student with what I'm going to call Joe. These 5-person committees, some of them have Joe in them, and some of them don't have Joe in them. Those are the only 2 possible committees. Well, the committees that don't have Joe in them, there would be 33C5 of those, because I could pick all 5 people not using Joe. On the other hand, if they have Joe, then I have to just pick 4 people from the remaining 33. And this is sort of an intuitive way to think about that. It's a really important formula because it leads to 1C0, 1C1. If I write down those two numbers, 1C0 is 1, and 1C1 is also 1. Anything C0 is 1, and anything C itself is 1. 2C0 is 1. Anything C0 is 1. 2C2 is 1. But as far as 2C1 goes, imagine I didn't know the formula for calculating it. All I knew was this property. I could say that 2C1 is 1C0 plus 1C1. In other words, the sum of those two. So 1 plus 1 is 2. I can do the same thing with 3C0. Running out of room, so 3C0, and this would be 3C3. But the other numbers, based on this property, 2C0 plus 2C1 is 3C1. 2C1 plus 2C2 is 3C2. And in doing so, we end up with the famous Pascal's triangle, where each number is the sum of the two numbers above it. So 10 plus 10 is 20. 10 plus 5 is 15, 6, 1. But because of this property that we just saw, we could jump to any number in Pascal's triangle. So this is like row 6, I call it. And this is number, we start with 0. The 0, first, second, third. So if I wanted to know what that number was, because I didn't know it, for example, I can calculate it by doing 6C4, which is the same thing as 6C2, which is 6 times 5 over 2, which is 15. So there's this relationship between Pascal's triangle and the combination numbers. And if you know Pascal's triangle, for enough rows you can get the combination numbers. And if you know the combination numbers, you can get Pascal's triangle. Okay, so that ends for special properties. Maybe I should mention a couple of P properties also. NPN is the same thing as N factorial. Like 5P5 is just the first 5 numbers of 5 factorial. NP1, is N. If I want a cone and they have N flavors, I can get N of them. And NP0 is 1 also. Again, a cone with no flavors would be a cone, one way. Okay, so that does it for the properties, special properties of, actually I'll mention one last thing because I put it on a test sometimes. I like this question. You know, we know that NCR is NPR over R factorial. So a question I've asked before is like, what's 1, 2, 3, 4 P3 over 1, 2, 3, 4 C3? And the answer is going to end up being 3 factorial equals 6, because if I rearrange this formula, it would turn into NPR over NCR equals R factorial. So basically there's 3 factorial times as many permutations as there are combinations. So if I divide them, I should get 6. Okay, that's going to do it for this video.